Now, when it comes to implementing our services, there's some important considerations about threading we have to be aware of. Now, this may seem a little bit counterintuitive, but all the callback methods on your services are run on your main application thread. That means that onCreate, onDestroy, onStartCommand are all called on the same thread that your UI events are called on. Right? And that may seem kind of confusing because you're like, well, I'm running things as a service because I don't want them to interfere with the user interface. And yeah, that's true. But it is our responsibility to actually dispatch that work onto a different thread. And so now we can do that using traditional threads if we want to, right? In other words, just kind of spin up our own threads, right? And in some cases, that may make a lot of sense, right? For example, in the onCreate, where I actually create a thread to monitor the GPS. Well, that thread's going to really have not much else to do except interact with the GPS. It's probably going to be pretty busy with that GPS handling. So spinning that up as its own thread makes a lot of sense. In general, though, a better way to do it is to use the executor service classes. Executor service, if you have more of a .NET background, is really kind of like a thread pool. It encapsulates a little bit more than that, but for the most part, you can think of an executor service as a thread pool. It basically allows you to go out there, create an instance of some centrally managed threads, one or more threads, and dispatch work onto it. Right? And that actually works out really well for us because we think about what a service is that we're getting tasks to do and dispatching work onto them. So the executor service implementations are a really good choice for that. In general, the way you get an instance of an executor service is to use the executors class. And basically, using that executors class, you can request a very specific type of service that you're looking for.